Okay, lesson 5.4, complex numbers, part 1. This is one of those jokes that's really funny to mathematicians because the irrational number, because that's what pi is irrational, saying to the imaginary number, hey, get real, because he's a non-real number. And the non-real number is telling the irrational number, hey, be rational. Okay, anyway, here we go. Kind of a basic rule here. Anytime you multiply under the radical, you can actually split them apart. And the same with division. You can split them apart separately. However, just kind of side note, you cannot divide by 0, so therefore b cannot be equal to 0. So if you have square root of 3 times 2, that could be square root of 3 times square root of 2, and same with your division. All right, let's apply it. You've had this in Algebra 1. This should be kind of a quick review. All right, square root 18. Now here's what I like to do. I like to find the largest perfect square number that goes into 18. So you've got 1 times 1, 2 times 2 is 4, 3 times 3 is 9. This is your perfect square number list. If you don't already know these kind of off the top of your head, then you need to, I think I'm missing one. 8 times 8, 9 times 9, 10 times 10, and of course there's 121 after that, and so on and so forth. Okay, well, 6 times 3 is 18, but 6 is not on this list, and neither is 3. You want to pick numbers on this list that go into 18. So 9 is what I'm going to go with right now. So I'm going to say square root 9 times square root 2 is equivalent to square root 18. And notice too as well, it's not 9 times 2. It's square root 9 times square root 2 that's equal to square root 18. All right, now if you look at that a little closer, hopefully we're on to the understanding that, hey, square root 9 is just 3. I oftentimes have kids like, how do you know which one to write the radical under? Well, if you were to type in square root 9 into your calculator, it comes out 3. So you have to write 3 as well. Square root 2 just tags along. You can't reduce it. There's no more numbers from the perfect square number list that go in there. So you're done. This is your answer. One way to check your work is to go ahead and put this in your calculator, put this in your calculator, and you get a decimal approximation. And they should be equivalent to each other. It doesn't always mean you have it simplified completely, but it does mean at least you have a simpler form of that. Students like a lot of times, why can't we just put a decimal? Because your decimal is an approximation, and this is exact. If you write this, you are officially smarter than your calculator. Are you convinced just because I said that? Okay, examples 2 through 5. So we got 2, 3, 4, and 5. All right, number 2, square root of 75. If you need that list, go back and look. The largest perfect square number is 25, but I don't write 25, I write square root 25. Square root 25 times square root 3. What is the square root of 25? If you put it in your calculator, it comes out to be 5, not square root 5. So I have 5 square root 3. Done. Square root of 56. Well, you could do like 8 times 7 is 56. You could divide it by 2. You get 28 times 2, and then you have 4. Oh, does 4 go into 56? Yeah, it does. So you're going to have square root 4 times square root, what is that, 14, I believe. Okay. Square root of 14 is just plain old 2. Square root of 14 does not break down anymore, so you leave it. 2 square root 14. All right, square root of 64x to the 4th. Well, I can divide those into separate thoughts. I can say, hey, deal with your numbers, deal with your letters. Square root of 64 is just plain old 8. Square root of x to the 4th, a lot of you may be able to just jump to the answer, but I'm going to write this out. Isn't that the square root of x squared times the square root of x squared? Like, really? Well, x squared times x squared, when you're multiplying with like bases, you add your exponents, it gives you this. All right? What is the square root of x squared? Just x. And what is the square root of x squared? Just x. Because the squares and the square roots kind of undo each other. So really, I have 8 times x. Well, I would write that as 8x squared. A lot of you will be able to just say, oh my gosh, square root of x to the 4th? Well, that's just x squared. I don't know. Maybe you can do that, maybe not. I'm sure if we do enough problems, you're going to get it. Okay, square root of 147. What's a perfect square number that goes into 147? Square root of a to the 5th, square root of b to the 9th. All right, I do believe, does 49 go in here maybe 3 times? Maybe I should grab my calculator and just do a quick double check. Let's see, 147 divided by 49. So I have square root 3 times square root 49. And if you don't know, you go to your calculator, you start dividing and say, hey, here's a perfect square number. Does 64 go into 147? Does 49? Does 36? You just keep trying until you get one. All right, here's what we're going to do with a to the 5th. I'm going to write square root of a squared times square root of a squared times square root of a. I'm going to run out of room for b to the 9th. Square root of b to the 9th. Oh, I should do second. Sorry, keep with my technique here. Times square root of b to the 2nd. Let's see, 2, 4, 6. Times square root of b to the 2nd. Oh, how horrible is this? Times square root of b. All right, so here I go. Square root of 3 does not break down, so I'm going to leave it. I'm going to give myself a little more room here. Square root of 49 is 7. Square root of a squared is just a. Square root of a squared is a. Oh, and then I have a square root a. Square root of b squared is b. Square root of b squared is b. This square root of b squared is b. This square root of b squared is b. And then this is square root b. Okay, now I'm going to put all the radicals together, and I'm going to put all the things that do not have radicals together. So we lead with our non-radicals. All right, 7 comes out. We've got a squared, because a times a is a squared. We've got b to the 4th. Now I do my radicals. I've got, I feel like an a. Oh, I need to do my 3 first. Never mind. Uh-oh. There for a minute, I thought my screen was not going to love me there. Square root of 3ab. Okay, now let me look that over for a second. B to the 4th, that's 8, and then I have another one. Okay, looks good. That is the answer on that, folks. Is that crazy? That's crazy. Okay, so one of the basic things here is square root of a squared comes out to be an a. This one doesn't have anything to go with it or cancel out, so you're left with the square root of a. Once again, if you have questions about that, right away when you come to class, start asking. Okay, so we can maybe just have a class discussion before we even get going. All right? All right, that was 2 through 5. Let's keep going here. Simplify, now we have division. Square root of 10 over square root of 81. Well, here's what we're going to do. Write it out separately. Square root of 10 over square root of 81. This is not going to change. However, the square root of 81 is just 9. I just want to point out your denominator cannot be a square root. You cannot have a radical in your denominator. It's illegal. You'll get a ticket. Yeah, a mathematical ticket. This does not break down anymore, so I'm going to leave it. That's the answer, square root of 10 over 9. Okay, let's try this out some more. So you got 7, 8, 9, and 10. Okay, number 7. I'm going to write it out square root of 7 over square root of 36. How nice that they gave us a perfect square number to put in the denominator. And then I leave square root 7 in the numerator, and I can't reduce it down, so I'm done. Number 8, square root of 32 over square root of 81. Crazy. Square root of 81 just works out to be 9. We like it when our denominators do not have irrational numbers in them because we have to rationalize them anyway. Okay, is there a perfect square number that goes into 32? Yeah, a lot of you might say 4. Well, 4 is not the largest one, and you have to find the largest one. So I'm going to go with 16 and 2. All right, square root of 16 is 4. You still have a square root of 2, and you still have this 9. Double check. Does 4 and 9 reduce? No, so I'm done. All right, square root of 192 and square root of 121. Well, let's see, the square root of 121 is 11. To be honest, I don't know off the top of my head. I think I know one, but let's go 192, start dividing. Dividing by your perfect square list. Let's see, does it divide by 100 and come out even? No. Does it divide by 81? No. Can you take 192 and divide by 64? It comes out even when you do that. So square root of 3 times the square root of 64 is 192. And what did I do? I grabbed my calculator and I started dividing until I got to the one that works. Okay? Square root of 64 comes out to be 8. I'm going to write that first. I still have a square root 3 that isn't going anywhere. And I've got an 11 in the denominator. I checked. Does 8 over 11 reduce? No. Does square root 3 break down anymore? No. I'm done. Number 10, square root of 350 divided by square root of 64. Now I have kids who are like, well, I don't know what to do, 350 is such a big number. Remember 25? Yeah. Take square root of 350 and divide by square root of 25. Okay, that'll at least get you somewhere. You may have to do more reducing later, but it so happens to be square root of 25 times square root of 14. Square root of 64, how nice, works out to be 8. Square root of 25 is 5. Square root of 14 over 8. 5 over 8 does not reduce, and square root of 14 is done, so I'm done with that problem. And done with that lesson. That is, there's so much there.